So welcome to our today's discussion. We are going to talk about the density of mixtures. And we are going to see a very simple way of determining the density of mixtures. And first, you need to understand how a mixture is formed. In this diagram here, we have two liquids that are being put together. And assuming that the two do not react, when they are put together, they form a mixture. So simply, a mixture is formed by putting two or more substances together such that they do not react. We need to know how to determine the density of a mixture. And the formula is simple. From the definition of densities, we know that the density of a substance is given by the mass of the substance divided by the volume or its volume. So in this case, where we are talking about a mixture, we are simply saying that the density of this mixture is equal to the mass of the mixture divided by the volume of the mixture. Two important points to note here. The mass of the mixture is given by the sum of the masses of individual substances. So if we have two substances here, to get the mass of the mixture, then you add the mass of substance 1 and the mass of substance 2. The same applies to volume. To get the volume of the mixture, you have to get the sum of the volumes of the two substances. You get volume 1 plus volume 2. And that is the values we are going to use in this given equation here. Now, to understand the problem well, we use a simple table here that analyzes everything. We have masses here, and we have the volumes in that row, and then the final row gives us how to determine the densities of all the substances. On top here, we have three items. We have substance 1, we have substance 2, and then we have the last column here is the mixture. We have substance 1 added to substance 2, so it's a mixture. And we assume that these two do not react. So now, how do we go about it? If we consider substance 1 as in a single substance with a mass m1 and a volume v1, then the density of this substance is simply the mass m1 divided by its volume v1. The same to substance 2 with mass m2 and volume v2. To get the density of the substance, we simply divide m2 by v2. Now, in the case of a mixture now, you have to determine the mass first and the volume. So in this case, the mass of the mixture in this case will be the m1 plus m2. So you have the sum of the masses of individual substances. Then the volume, again, it is the sum of the volumes of the individual substances. So that gives us the mass of this mixture and the volume of the mixture. Now with those two, we can easily determine the density of the mixture by simply taking the mass of the mixture divided by the volume of the mixture. Simple formula but then you need to understand what is getting here and what is getting here. So it is the density of the mixture. We take the sum of the masses divided by the sum of the volumes of the individual substances. Now, let us use that to solve a question. Example 1, you are given that a mixture is formed by putting 100 cubic centimeter of fresh water of density 1000 kilogram per cubic centimeter together with 150 grams of seawater of density 1030 kilogram per cubic meter. Determine the density of the mixture. How do you get the density of the mixture? The first step in this case, you need to analyze the question first to understand what is given and what you need in order to be able to determine the density of the mixture. So we use this table, and this table is important, makes things easy. It helps us to visualize the given problem. So here we take the substance 1 here to be the fresh water and the substance 2 to be the sea water. So now for the fresh water substance 1, we are given the volume 100. So put that in the right box. Then we are given the density of fresh water. So you put that again in the right box. For the substance 2, you are given the mass. So be careful. Put that in the right box here, 150 grams. Then you are also given the density, put it in the right box. That is what we are given. So you see, in this table, we have empty boxes, no values here. We don't have the mass of substance 1. We don't have the volume of substance 2. And therefore, there is no way we can determine the mass of the mixture and the volume of the mixture. So to get these two, you must first get these two here. You have to find the mass, you have to find the volume of these substances. Now, how do you determine the mass of substance 1? We go back to our relation and say that density is given by mass over volume. So simply, you want M1. So you need to make M1 the subject of the formula. So if you are given that density density 1 is given by mass 1 over volume 1. So what you do here, just multiply both sides by V1. Multiply this side again by V1. What you are going to see is that this will cancel that one, and then you are left with the V1 is equal to that is you have V1 times density 1 is equal to our mass M1. So simply we can see that the volume of the mass M1 is equal to the volume V1 times the density rho 1. So in this case here, if we multiply by V1, you see that that will give us mass 1 is equal to rho 1 times V1. and we are given this one. So we simply substitute the values. We are going to get M1 as 100. So back to our table, we put the value 100 in the right place. Okay. So again, now we need to get the mass of the mixture. We have the mass of substance 1, we have the mass of substance 2, but we do not have the mass of the mixture. So we simply add. You are going to get 250 grams. Right now we don't have the volume of the mixture, and something is missing here. So we need to determine this one first, so that we can get the volume of the mixture. So again, we go back to the formula for density. We know that density is given by mass over volume. So the density of substance 2 is the mass of substance 2 divided by the volume of substance 2. What you need here, because we need to get the volume, you have to make V the subject of the formula. And how do we do that? Okay, right here. Let me wrap this one. Okay, so we have density of substance 2 is equal to the mass of for substance 2 divided by the volume of substance 2. And we need to make V2 the subject of the formula. In this case, first you need to multiply through by V2, multiply this other side by V2. What will happen is that this V2 here will cancel this V2. So what we have here, we shall have V2 times density rho 2 is equal to the mass M2. Okay, and because we want the volume V2, then you need to divide here by the density rho 2 and do the same to the other side, rho 2. You find that this cancels this one, and we are left with the V2 is equal to the mass M2 divided by the density rho 2. So now we can see that volume is given by mass times the volume, that is mass divided by the density. So that is what we have done here. You find that whatever we have done, those two steps is the same by multiplying by V2 and dividing by rho 2. So you are going to get V2 equal to M2 over rho 2. We have the mass of our substance 2, and we have the density of our substance 2. So you simply substitute, and if you solve that, you are going to get the volume of substance 2 as 145.63 cubic centimeters. So we place that in the right box. And therefore you can see now we have everything that we need to determine the volume of the mixture and also the mass of the mixture. We have done this one. So this is 250 grams. You are simply adding, and then the volume of the mixture you simply add again. You'll get 245.63, and this is centimeters, that is cubic centimeters. Right. So you can see now we have the volume of the mixture and we have the mass of the mixture. Now we need now to determine the density of the mixture. So to get the density of the mixture, we need to go back to our formula. We know that the density of mixture is given by the mass of the mixture divided by the volume of the mixture. And therefore, because we have these two, we have the mass here, we have the volume here, we simply substitute that is 250 divided by 245.63. You're going to get your density of the mixture is 1.01779. This is grams per cubic centimeters. Then we can place that in the right box. So now you can see that our table is complete. Okay. So in summary, this table is very important, and the main role that it plays here is to visualize the whole problem, to know what is being given in the question, what the question wants you to do, and when do you start. So we can see that if you have two substances here with the masses M1, M2, and the volumes V1 and V2, we easily get the masses, that is the mass and the volume of the mixture, by saying that the mass is the sum of the individual masses and the volume is the sum of the volumes of the individual substances. And then you must remember that the density of the mixture here will be given by the mass of the mixture divided by the volume of the mixture. Well, I am sure you are now ready for a challenge. Try to use the same method and solve this example too. You are given a broth meant of mixing molten copper and tin. If 100 kilogram of the mixture contains 80% by mass of copper and 20% by mass of tin, calculate the density of the broth. Then you are given that the density of copper is 8,900 kilogram per cubic meter, and density of tin is 7,000 kilogram per cubic meter. The answer to this question is 8,439 kilogram per cubic meter. See if you can reproduce the answer.